Well, greetings everybody. Here's a problem that I have found on our assignment on my math lab, and I'd like to show you how to do it. Here's what it says. It says to solve this indefinite integral using integration by parts. And I might notice that some of these questions on my math lab have specific instructions. It doesn't just say to solve it, but it says to solve it by a certain method, integration by parts. So let's do that. So I've got 5 theta secant squared theta d theta. So there's my integral. Here's the integration by parts formula that is my objective to use. Okay, and let's pause for a second. Speaking of formulas, let me show you something that I've included on Canvas. So if we go to Canvas and we look under modules and we look under the test 1 module, you see this, and for example, this page videos for assignment number 1, that's where you're finding this video. But here is another link, another page, suggested formulas for test 1. Okay, so I might suggest you open that up because through these first 4 assignments for test 1, there are a lot of formulas that we might need. Integration by parts is one of them. If you open that page, here's what you get. I have it divided into trig identities, definitions of sine, cosine, tangent, so on, derivatives, and from there, everything that I could think of that you might need. Here's integration by parts. So you can find it on there. There are other ways that you could express this integration by parts formula, but they all express the same truth, even if the notation is a little bit different. Okay, now what I've done is I've written that here. Here's the aim when we use integration by parts. I look at this integral as containing 2 functions multiplied together, 5 theta secant squared theta. In terms of using integration by parts, I'd see it as one of those functions is a function f of x, and the other would be a function g prime of x. And I have to decide which function is f of x and which is g prime. Okay? And once I make that decision, the integration by parts formula plays out over here on the right-hand side, and I evaluate that to completion. I get my answer. All right, so that's the formula and the objective. Now, here's how I would solve this one. I've got 5 theta secant squared theta d theta. I need to decide which of those functions is f and which is g prime. Okay, so I look at 5 theta and secant squared theta, and it could be, it's like a coin flip. It could go either way. Maybe f is 5 theta, or the other option, maybe f is secant squared theta. There is a strategy for choosing. I don't want to go into it too much right now because if you look under videos for assignment 1, okay, in my first video on integration by parts, which you see right here, I explain a simple strategy for choosing what is f and what is g prime when you use integration by parts. Okay, so here's what I chose based on that strategy. F of theta is 5 theta. G prime of theta is secant squared theta. Okay, so I chose those. That's what will make integration by parts work, is that choice. Now, I have to figure out as a consequence of that what f prime theta and what g of theta are. Okay, these are consequences of those choices. Do I need all of them? I need all of them because look at the formula. You start off by seeing your problem in terms of 2 functions, f and g prime. But the way that the formula plays out is, well, I need f, I need g, I need f prime, and I need g again. So, you know, all of them are in play. F and f prime, g and g prime, they're all part of it, okay? So I choose these. Now think of it like this. I chose f of theta to be 5 theta, that right there. If that's the case, what's f prime theta? Well, what is the derivative of 5 theta? It'd be just 5. Okay, so that's why f prime theta is 5. Now, if g prime theta is secant squared theta, now that's my choice. That's the way I'm setting up integration by parts, is to choose it that way. But if g prime theta is secant squared theta, then what is g of theta? Well, I might phrase it like this. I might say, what do you take the derivative of to get secant squared theta? Derivative of what is secant squared theta? And maybe from there, I could look at my formula page and maybe see, like, look through my derivatives, and the derivative of tangent is secant squared. Okay, so that's what I want. That's why it says here g of theta is tangent theta. And sure enough, that's consistent. Because if g of theta is tangent theta, then g prime would be secant squared. And all of these are consistent with each other. So I'll choose these, and then I'll figure these out down here. Now, I would say that with g prime being in your choice, the way you solve for g may vary. Here, I found it on a formula page. It's just a matter of fact that the derivative of tangent is secant squared. So that's what it is. Here's my setup. But it might be that it takes some work to solve for g of theta. Now, you can see lots of examples of how that might play out if you look at this video series that I already have posted. Okay, so let's get back to it. Now, here's my choice in my setup. Here's how that integration by parts formula plays out right here. Here's my problem. I aim to solve what is the indefinite integral of 5 theta secant squared theta d theta. And here it is. It's 5 theta tangent theta minus the indefinite integral of 5 tangent theta d theta. Okay, now it might seem like I have my answer because that is in fact the formula. Do you see this right here? It's this with my setup expressed, okay? But I need to evaluate that part to completion to get my final answer. So now I have to say, all right, what is the indefinite integral of 5 tangent theta d theta? Okay. Now, how you solve that? I mean, we have several methods available to us. It might be that that is on my formula sheet somewhere. Okay. Could be. All right. We'll look and see if we can find it. Or it might be that I have to use u substitution or something like that. So let's talk about how I would solve this part and what options we have. And then if we do that, we'll have our answer. The only thing keeping us from our final answer to that initial problem is solving this. Okay. All right. So let's see. How would you solve the indefinite integral of 5 tangent theta d theta? Well, okay, one method, you can look up the answer or use a calculator, something like that. Those methods are available to us. I mean, I told you that maybe it's somewhere on this formula sheet. I think I see it right there. Okay, the antiderivative of tangent of u du with some u substitution. I can get that. All right. Or use a calculator or something like that. Now, I'll say that those methods are on the table if the instructions allow. Okay. As far as our assignments go, where you will turn in work, which for the tests, I will have you turn in some work. I'll give you instructions on the detail of the work that I'd like to see. Okay, if it says that you can look up the answer at a certain point or use a calculator at a certain point in the problem, then you do that. Otherwise, if it says, say, use substitution, then okay, then that's what we'll do. So let's focus on the second method. Looking up the answer is not that hard to do, or using a calculator is not that hard to do either. So what if that wasn't on the table? What's our other method? U substitution. So let me show you this. Let me show you how you can solve the indefinite integral of 5 tangent theta d theta with u substitution. The formula that becomes applicable within the context of u substitution is this. 1 over u du is natural log absolute value of u plus c. Okay? So even if we use u substitution, there must be some foundational formula that we end up using. Okay? So my goal at this point is to show you how u substitution can make this work for this. Okay? So how would 5 tangent theta ever possibly look like 1 over u du? How would it look like a fraction? Well, tangent itself through identity could be a fraction. Tangent is sine over cosine. So 5 tangent could be seen as 5 sine over cosine. Now say I disassemble that. And here's what I'm going for. This is what I think this integral can become with some manipulation. So I'll separate sine over cosine as 1 over cosine times sine. The 1 over cosine will become my 1 over u, and the sine theta d theta will become the du. Watch. So here's how the u substitution is going to work. U will be cosine, okay? And then as a consequence of that, du will be negative sine theta d theta. Now this doesn't directly substitute. I've got sine theta d theta, but I'll multiply both sides of this by -1, and I'll substitute that way. For u, I'll substitute cosine. For sine theta d theta, I'll substitute -1 times du. Okay, I'll get this. I can remove this constant of 5 times -1, which is -5 from the integral. I'm left with 1 over u du, whose answer is natural log absolute value of u plus c. Okay, or if you'd like, -5 natural log absolute cosine theta plus c. Now that would complete our problem for us. This thing right here, 5 tangent theta d theta, well, that works out on its own to be -5 natural log absolute cosine. So here's my final answer with that last substitution made. Okay, in other words, take this with that part just solved to get this, and then we're done. Okay, now if I go back to this question on my math lab, the way it's presented there, one part of this question is what the setup would be. Okay, and notice this selection A right there appears in my work, and then when I solve this second integral left there, I got that final answer. Okay, all right, so you can see it all there in terms of the answer template on my math lab as being consistent with what I've done. Now, one more thing I want to show you. We're doing math here. Okay, maybe there aren't a whole lot of numbers, but it is math. At the end of the day, everything is a number here. Can this be verified? Now, when I say this, I'm not saying that I want you to verify every answer that you get, because that could take too long. All right, but I think you should know that it is possible, and I think you should know how, all right, as part of having a complete understanding. So what would it mean for this to be correct? For the indefinite integral of 5 theta secant squared theta d theta to be 5 theta tangent theta, etc. Well, it would mean this. If you took the derivative of this expression that I'm saying is the answer, I would get 5 theta secant squared theta. That's why this is sometimes referred to as the antiderivative. All right, so let's see if that does in fact happen. If I find the derivative with respect to theta of this supposed correct answer, I should get 5 theta secant squared theta. Now, partially I'm doing this because I'd like you to see how it's done and what it means for this answer to be correct, this independent verification. But another part of it is that there's a lot to know by the time you get to Calculus 2. You know, not only do I need to know how to solve this problem, perhaps with some navigating of this formula sheet, okay? But like I need to know how to find, you know, and use the product rule and the chain rule, stuff that was learned in Calculus 1. It still comes up in Calculus 2, okay? So here goes. The derivative of this requires the product rule for 5 theta times tangent theta, which plays out like that. And the chain rule for 5 natural log absolute cosine theta, which plays out like that. And the derivative of any constant is 0, which is why this constant of integration appears in the answer at all. All right, so look at that. If you're okay with that, you're probably okay as far as Calculus 1 goes. If this is something that you would struggle with a lot to do along with me right here, then it's something that we should talk about. Because like I said, I'll have to know Calculus 1 fairly well to get through Calculus 2. All right. So in any case, with some simplifying, I get like so. The 5 tangent thetas cancel. I get 5 theta secant squared theta, which is what I should have gotten if this answer was correct all along. Okay, so that's how it works. That's the problem and a little bit more than you need to know. But how about this? I'll leave it with you now. If you can solve the equivalent one of this in your assignment, it might have a different constant right there, but otherwise it'd be the same concept. Good. If you struggle with it or anything else, let me know and I can help you out.